Good afternoon, good morning, and welcome to the Tech Talk. Can AI really improve agent productivity? The next 45 minutes will be an in-depth analysis of the impact AI can have in the contact center by looking at very specific areas of common workflows that contact center agents do every single day. The Tech Talk is led by Heather Reed, one of our research scientists at ASAPP. She develops and runs statistical analysis of the performance of different AI models across vast data sets. She also applies her understanding of AI and statistical analysis to gain new and in-depth insights into ASAPP solutions for customers like JetBlue, American Airlines, Charter, Dish, and many more. We encourage you to ask questions as we go along via the question and chat panel on your Zoom menu. We have time at the end for live Q&A, hopefully, and it's a great opportunity to get the opinion of one of the industry's leaders in AI modeling. Automatic speech recognition, natural language processing, machine learning, and task-oriented dialogue. The result is a set of CX solutions for the contact center used by some of the world's largest companies who are transforming their customer experience by multiplying agent productivity, getting real-time operational intelligence, and delighting every customer. Today, you are going to hear in-depth analysis of how AI can work in very specific areas around agent productivity. But if you are interested in learning how to evaluate AI agent assist solutions in their totality, based on the most common requirements from the world's largest contact centers, schedule a briefing with us for 30 minutes via email at ask@asap.com. And with that, let me welcome Heather. Heather, good morning.
Hi, thanks, Teresa. It's a pleasure to be here today. I'm excited to talk about how we measure artificial intelligence's impact on agent productivity. When we talk about AI to address challenges around customer experience, there really is a wide range of opportunities you can apply artificial intelligence to. Today, I'm going to focus on just one area of customer experience, and that's agent productivity, and how AI can help agents be their best with integrated automation. Okay, so let's start with AI for automated responses in messaging and chat. And before I jump into analyzing AI for automated responses, let me just ground us in what I mean. So when an agent is messaging with a customer, at every turn of the conversation, we make recommendations on what the agent should say to the customer. When you apply artificial intelligence for chat or messaging, the AI looks at the whole conversation, not just the last message. That way it's incorporating the entire context into the predictions that we're making for the agent. It should support multiple recommendation techniques, whether before or after an agent has started typing. It should be trained on the conversational data across the agent population, and it should be personalized for individual agent behavior as well. I'll explain in a bit about why the personalization is so important. AI should provide a custom response library for agents that self-updates so that agents are always presented with the most recent responses that they're most likely to use. So with that, let's jump into how it actually works and how we measure the performance with respect to agent productivity. So when we think about agent productivity, metrics like handle time, concurrency, and throughput typically come to mind. These are the metrics that we ultimately want to impact with artificial intelligence. However, there are a lot of confounders or other variables that are not related to the AI that are also impacting metrics like agent handle time, concurrency, and throughput. So for example, if too many agents are scheduled for a certain time of day and there's not enough customer volume, throughput per agent will be lower, right? Because there aren't enough customers for the agents. Or if there's, for an example, an internet outage, then there will be a shift in what customers are reaching out about. So we call that a distribution shift, which will affect handle times. So both of these things are, we call them confounding effects about what impacts throughput, handle time, concurrency. But what we really want to do is isolate the effect of AI on productivity by considering all of these other external effects as well. So to really understand how AI impacts agent productivity, we evaluate the AI at the level where it operates. And for automated responses, artificial intelligence operates at the message or the utterance level. Okay, so if we're going to analyze the AI impact at the utterance level, we have to break down what happens when an agent composes a response to a customer, which is illustrated in this schematic. So we have a previous utterance, all the way to the left here. And then what happens is there's a period of time before the agent does anything. We call this the time to action. Then the agent might, the agent might be handling another customer or performing work in some external system, looking up information, reading the customer's response. That's all incorporated in the time to action. Then there's this timestamp when the agent first takes action to compose a message. They could type a character, or they could click on an automated response. They could Control V, paste something into the composer box. And then they start composing their message. And then there's the timestamp when the last composed message action occurs. And then we call that time between the first and last composed actions the crafting time. That's how long it takes the agent to literally craft a message. And then finally, there's typically a small amount of time between when the agent finishes composing the message and when they ultimately send the message. And we call this the dwell time. And so all three of these times, the time to action, the crafting time, and the dwell time, sum up to the agent's response time. And so when we're thinking about designing an AI model, or how we're going to evaluate how an AI model impacts agent productivity, we want to evaluate how the AI impacts these response time metrics, because they're more invariant to changes in external effects than metrics like handle time and concurrency. Once we measure the impact on response time, we can then aggregate those savings up to impacts on handle time, concurrency, and throughput, which is helpful because those are the metrics that we typically look to as an industry when we're trying to think about agent productivity. Okay, so that was how we evaluate an AI model's impact on agent productivity at the message level. Now let's dive into what an AI model actually looks like and why the AI model architecture for the problem that you're trying to solve is so important. So as I mentioned before, an AI model to drive automated responses for agents should be evaluated and designed at the agent message level. Let me show you what that looks like. So for our model, what we want is for the model to take in as input the conversational context up to some point in the conversation. And then the prediction that we want out of this model is what the agent should say next. And so that's exactly how we train the AI model. What we do is we take a conversation up to a point in time, and then we show the model that conversation, and then 1,000 possible agent responses, one of which is the actual true agent response. And we ask the model to choose which is the right response out of all of those 1,000 possible responses. And then we repeat this millions of times across millions of conversations and across all agents. What happens is the model learns what are the most important words and phrases in the conversation that are predictive of what the agent should say next. And you can see that happening in this example here. The model has learned that the words and phrases in the darkest colors here are the most predictive of what the agent should say next, which is highlighted on the right here. So it's learned that things like diagnostic request, instructions for opening the app, connecting, those are all predictive of something like, I'm happy to inform you I was able to get the diagnostic result, etc. So that's an extremely oversimplified description of how we train the model. So when an agent is chatting with a customer, the model has already been trained to ingest the conversation and then predict what the agent should say next. These predicted responses are then suggested to the agent, and the agent can use them. Using the AI suggested responses then reduces the agent's crafting time and their response time, and in turn enables higher agent productivity. What I want to pause and highlight here, and that I hope is a big takeaway from this, is how important the right model architecture is when we're designing AI models. The machine learning objective that we're using to train this model is to literally predict what the agent should say next. Other approaches that we've evaluated and that I've seen might use something like clustering or topic modeling to identify maybe the type of message that an agent might say next. Or other approaches might have some hand-built rules about what to suggest to agents as a function of manually prescribed keywords or other metadata. But when we've evaluated these other approaches internally, we've seen that they're just not precise enough. So if the suggested response to agents, aren't precisely what the agent wants to say, then agents won't use the responses. The type of model that we're using here is doing just that. It's predicting exactly what the agent should say. And doing this well is really difficult. And it's an area of active research in deep learning models. And it's the main focus of ASAP's research team. Okay, so I just explained how one of our AI models works. That AI model is really only one component of automated responses for chat. There are a lot of other components that are required to make automated responses successful. We actually have several AI models that are working together. And then we have the entire response model that I just explained, but we also have autocomplete models that are predicting the rest of what an agent wants to say, given what they've already typed so far in that composer box for that message. So that's the model part, but then there's also the sources of content, the response sources from which the models then retrieve the content from. And the response sources are extremely important because the way that the automated responses features works is to use the AI models to retrieve responses from a list of content. We can have really powerful AI models, but if we only allow them to retrieve from limited content, then they won't be able to suggest the right things to the agents at the right time. So we leverage artificial intelligence and machine learning to also learn what should be included in the response list sources. And then the last component of successful and impactful AI-driven automated responses is personalization. We've found over the years that when models and response sources are personalized to organizations, teams, and agents, that agents are not only more likely to use the suggested responses, but they'll actually be more effective and impactful as well. So for example, if the AI suggests something to an agent that is semantically similar to what the agent wants to say, but it's not quite how the agent wants to say it, then we risk that either the agent may not use the suggestion at all, or that agent will use the suggestion, but then edit it so that it's more in that agent's tone. And when the agent uses the suggestion, but then edits it, that editing time increases that agent's crafting time and the response time, and ultimately the handle time and throughput. So when agents edit responses, it erodes any productivity that we gained by using the responses in the first place. So what we really want is for agents to use the automated suggestions and not edit them. This result is the most impactful on agent productivity. Okay, so let's look at some real customer results. So what we're looking at here is the impact savings on agent response time as a function of how often agents use the automated responses. And the colors here are 6 different customers. So we're defining impact here as the time savings, the response time savings compared to when agents do not use automated responses. So what we see on the y-axis is that on average, agents are saving about 15 to 25 seconds of response time every time they use an automated response. And that savings comes from reduced crafting time and reduced time to action. If the agent no longer needs to go and look up information to respond to the customer. And so if agents are saving 15 to 25 seconds every time they use an automated response, and they use the automated responses for most of their messages to customers, this really quickly adds up to significant agent productivity improvements, which I will show in a couple of slides. Okay, so I showed what the impact looks like on a per usage basis, but it's also important to look at how often agents are using automated responses so that we can multiply the impact per usage times the overall usage to get the total impact on handle time. And so here's what that usage has looked like for our automated responses over time with one of our customers. And so you can see on the y-axis, we have the percent of all agent messages that have been powered by our AI. So 4 years ago, we had a pretty simple AI model and automated responses feature with no agent personalization. And you can see, usage starts off at only about 20%. However, over time, we incorporated more sophisticated AI model architectures. We included the ability to predict autocompletes. We also included personalization in both the AI models. So the AI model is learning how this agent should respond, but also the response sources. So we've learned, how different agents like to respond to customers. And as a result of this continuous model improvement and continuous data-driven impact evaluations, like we're walking through now, we've seen the usage rates grow to 75% today. So that means that for 75 to 80% of messages that agents send, they're leveraging our automated responses. And another really important aspect of measuring the impact of automated responses on agent productivity is to consider which types of messages are being automated. So what we're looking at here is what that 75%-ish usage looks like through the conversation. So typically, agents use automated responses more at the beginnings and the ends of conversations, which is what you're seeing here. There's a higher usage rate for greetings and closings. And the reason for this is that it's easier to automate those types of responses. The AI models learn to predict those responses really well because agents typically begin and end conversations very similarly across different types of conversations. However, when evaluating the impact of automated responses on agent productivity, automating the beginnings and endings of conversations is actually not that impactful. And there's a good reason for this. When agents do not have automated responses suggested to them, what they will typically do is they'll have a notepad or a Word doc where they have all of their favorite responses already available. And so what they can do is when they have a new customer comes in, they can very quickly navigate over to that notepad and copy and paste those responses into their chats. So if you think about what that copy and paste means in terms of response times, response times for those types of messages, the beginnings and the endings, will already be really low because agents are already pretty effective at copy and pasting. And so if you automate that work for them, just the beginnings and the ends, all you're really saving is 5 to 10 seconds of response time because they're already good at that. What we really see is the longest response times are in the middles of conversations where agents either do not have saved responses readily available in a notepad, or agents they may not know exactly what to say, and they may take a long time to think about how to respond to the customer, or they might take some time to look up information that they need to respond to a customer. And if you look at this plot, our AI, our automated responses, is automating over half of the responses in the middles of the conversations. And this is where we've seen the biggest impact on response time and agent productivity occur. So when I'm evaluating different AI solutions for automated responses, while the most rigorous thing to do is to evaluate the impact on the response times, and ultimately the handle times, one pretty good proxy for impact on agent productivity is the agent usage of the features, as a function of all of the messages that they send, what percent of those are they using automated responses for? If agents are only expected to use the automated responses for 20% of their messages, then what's happening is that the agents are likely only using the responses to automate the beginnings and the ends of conversations. And as we just saw, just the beginnings and the ends are not significantly impacting agent productivity. It's really only when we can automate the hardest parts of the conversation that we see the largest gains. Okay, so we talked about what the average impact looks like on a per usage basis in terms of response time. And we talked about what the total usage rate looks like, about 75 to 80% of all agent messages. And now we can look at how those utterance level productivity gains aggregate up to real agent productivity metrics that operations teams use. So here we're looking at agent handle time. And what we see is that we're saving about 160 seconds per conversation. And for a 17-minute conversation, that's about 16% of an agent's handle time. And so while we tend to think about how automated responses impact the response times and productivity of the conversations that they're used in, there's another component to agent productivity that automated responses impacts, and that's agent concurrency, where concurrency is the number of simultaneous conversations an agent can handle. And so because the automated responses are removing the time and the effort to respond to customers, organizations have been able to increase their concurrency for agents without compromising agent productivity or negatively impacting customer satisfaction. And here's what some improvements in concurrency look like. So on average, we've enabled an additional 0.12 issues, meaning that if an agent was previously averaging a concurrency of 1.5 issues, we've seen their average concurrency increase to 1.62 issues. Okay, and finally, we want to look at throughput, as we think of throughput as the really true and best metric for agent productivity. So we think of throughput as the number of issues per agent per some unit of time, like hour. And it's a function of both concurrency and agent handle time. And it's really, concurrency divided by agent handle time. And so we can affect throughput by doing two things. We can reduce the handle time, or we can increase concurrency. And so when we do that, we consider both the improvements to agent handle time that we've made and improvements to agent concurrency. They combine for an improvement of about 0.8 additional issues per hour for an agent, which is about 35% throughput gain, which is pretty substantial. Okay, so some takeaways for the AI-driven automated responses. So AI models, when we're thinking about how we should evaluate them, they really should be trained and evaluated at the utterance level, because that's where they're operating, right? We're suggesting content and responses to the agents, every time they send a message. And so it makes sense to train a model to predict exactly that. And it also makes sense to evaluate what impact you're having on agent response time at the utterance level, so that you can aggregate those savings up to handle time and throughput. Personalized AI models paired with machine learning sourced content results in the most impactful solutions. And the reason for that is because we really want agents using the responses and not editing those responses, because as they edit responses, it erodes any productivity gains that we've measured or that we've observed with the AI responses. And when we think about agent usage of automated responses, the most impact, the largest impact comes from automating the middles of the conversations. And because of this, we've seen smaller impacts when usage rates are only about 10 to 20%, because when they're only 10 to 20%, it's mainly the beginnings and the ends of conversations that are being automated.
Heather, I know we were going to save some questions for the end, but there are a couple questions just around this topic. So I thought we'd just pause and ask. One question that came in is, what's the time frame for the AI model learning over time? Is that, I'm assuming that's dependent on the customer and the implementation.
Yeah, so we retrain our AI models periodically. The frequency depends on the customer and how many agents and how large, the volume is, but anywhere from weekly to daily. And so the time frame is, if you have historical data, then we typically like to have anywhere from 200,000 to 2 million conversations to train an AI model. And then it's put into production live. And then what we tend to see happen is that the usage rates might start off at that 10 to 20% because the AI model is, it's like I mentioned, it's really easy to learn what to suggest for those. But then we see usage rates steadily increase over about 3 to 5 weeks. And the reason for that is agents are getting used to the features, right? They're adding their own personalized content. But then the other aspect of that that's really important is that when AI models are learning, and they're learning, when they're initially learning from data that that maybe agents have not had automated responses, the language that the AI models are learning is initially really varied. And so agents might say the same thing across different agents. They might semantically ask for the same thing. For example, where is your, what is your zip code? But because agents are freehand typing those responses, they might ask for a zip code in 1,000 different ways. And so the AI has to initially learn that the 1,000 different ways of asking for a zip code is just one way, should just be one way of asking for a zip code. And so as agents start to use the responses more and more, their language becomes less varied and more precise. And that makes it easier for the AI model to continue learning. So it's those two things that are causing AI models, or the usage of AI models, to improve in those first weeks. It's agents getting used to the features and adding their own content, but then it's the AI model continuously learning as the language that agents are using becomes more concise.
Great. I'll ask one last question here and then I'll let us move on. So someone writes, I'm assuming that before you implement, you're getting some type of training data for the model. What happens when there's no good training data?
Yeah, so if there's no good training data, we can do one of two things, and we've done both. So the first is we can use a generic model that is not trained on any specific customer. And what that will be really good at is the greetings and the closings, because those tend to not be very customer specific. And then the same thing will happen, right? Agents will use it. And since the models are retrained often, the model will learn what this customer and this agent's language typically looks like. I think that's what that question was getting at.
Great. All right, I'll let you move on.
Okay. So we talked about automated responses, and now we can talk about call summaries. So before I jump into analyzing artificial intelligence for conversation summaries, let me just ground us in what I mean. When you apply AI in this context, AI should be trained in the context of a contact center and trained specifically, against your data. It should summarize every call and salient message interaction within the contact center. Summaries of an interaction should contain the relevant parts of the conversation, including the reason the customer calls in or chats in, the resolution steps taken, and the results of the interaction. And you should ensure that the results of the AI-driven call summaries are in a format that you can use to gain powerful insights into the business. So, how to grow revenue, how to build better products, for example. So the data should be exportable in both a human readable format and for analytics ready formats. And so agents are required to take these notes that are summarizing the salient points of the conversation. And so I'll show you what that looks like. Okay, so when we think about evaluating automated call summaries, we want to think about how the automated summaries are impacting agents' work. And for summaries, it's helpful to think about what typical note-taking without AI looks like. So when we measured data from agents who do not have automated summaries, and this is typically what calls look like. So this schematic represents a call, and the red boxes are the time agents spend taking notes. And we measured that agents typically take between 2 and 5 separate notes during the call, with an average of about 4. And they tend to take notes when a noteworthy thing occurs. So for example, after the customer calls in and explains their issue, the agent will take a note that says something like, customer called in to ask why their bill is so high. And then if the agent does any work on behalf of the customer, they'll take notes right after, about what they did, so that agents, they do it when they take notes when the noteworthy thing happens, so they don't have to remember at the end. And again, this is without any artificial intelligence. So we measured that when agents take notes during the call, it typically takes them on average 15 to 20 seconds per note. And then you multiply that by 4 separate times, resulting in a total note-taking composition of 72 seconds on average, plus 10 total seconds we measured of context switching. So they might have to switch from their note-taking view versus some other tool that they might be using to help solve the customer's problem. We also measured that on 30% of their calls, agents are actually finishing the disposition notes or the summary notes from their previous call, and this typically took them 20 seconds to do. So all of this note-taking time results in 88 seconds of total note-taking. What's important to note is that the 88 seconds of note-taking is not performed during these natural pauses on the call, or even really when the customer is talking. What we actually measured that happens is that agents end up pausing the conversation to take the note. They'll either say something like, okay, one moment while I pull this up for you, or one moment while I write this down. And while it doesn't seem like a big deal to do this, what's happening is that the agent is causing a delay in the conversation and ultimately prolonging the call handle time. And we've measured that when agents do that, it increases the call by 88 seconds on average. And for a 15-minute call, this is about 9.7% of the handle time. And so, so the previous slide showed what are measurements from agents who are not using automated summaries and who are manually note-taking during the call. So that's what the situation looks like. And we saw that they couldn't take notes effectively without increasing the call time. Now we're looking at what happens when agents are encouraged to not take notes during the call with the customer. What we see here is that this is a typical timeline of a voice call where the pink and purple vertical bars here are either the customer or the agent speaking. And what we measured is that for 91% of the call on average, someone is actively speaking. And that pauses between customer or agent utterances are an average of only 2 seconds, which is not long enough for an agent to take a note about the conversation. Okay, so we saw what the situation looks like for when agents are not using automated summaries. Now let's look at what is happening when they do use automated summaries. So what does this mean for time savings? So without AI, agents are adding that 88 seconds to their call times. With automated summaries, we're moving the in-call note-taking. And when we do that, agents can focus on solving the customer's issue. I know this talk is about agent productivity, but we've also measured the correlation between agent response time and customer satisfaction, and it's pretty significant. So customers can get pretty annoyed when agents have to, when they have these long pauses in the conversation. So with automated summaries, agents spend just 15 seconds interacting with the automated summaries. This might entail adding, a quick sentence. But if you look at the distribution of what the summary time looks like, you see that there's this big spike at 0 seconds. This indicates that for many calls, agents are actually not editing the summaries at all, and they accept the summaries as is, which is why when the editing time is 0, they see the summaries, they look it over, it looks good, they move on to the next call. But on some calls, the agent might need to clarify something or append something. And so on average, when that happens, the interaction time is 15.5 seconds. So what all of this means is that we reduce the summarization time from 88 seconds to 15.5 seconds, which for a 15-minute call is a reduction in handle time of about 8.1%. And we're seeing that as the summary models continue to learn and summaries become better, that 15.5 seconds will reduce to nearly 0 as agents, increasingly feel that they don't need to edit the summaries. Okay. So some takeaways for AI-driven call summaries. We analyze how conversation summaries are impacting agents' workload. And it's more than you think, right? You think agents should be pretty effective at just jotting down a quick note during the call, but those small time increases, of 15, 20 seconds, they add up because agents do it on average 4 times per call. And it pretty significantly increases the call handle time. And then when thinking about how AI-driven call summary models are trained, they should be trained within the context of the contact centers, and on your data. And we really want 2 types of call summary formats. We want a human readable format so that the agent can quickly, scan the paragraph that we present to them, and that it can be usable by the next agent. But then we also want data in this exportable analytics ready format, like a table, so that you can mine it for business insights. So that was it around call summaries. I hope all of this was helpful. And with that, I'll turn it back to Teresa. Teresa, I don't know if you're talking, but you might be on mute.
Thanks, Heather. Thanks for that. I was on mute. I want to quickly summarize, and then I'm going to try to answer a couple of questions. If we didn't get to your questions today, we will email you afterwards. So today you've heard analysis of AI results from some of the largest contact centers in the world. We hope you can see how machine learning enables continuous improvement, and we're hoping you're walking away with an understanding of how AI-driven predictions enable better results than just simple rules-based systems. Heather, I'm going to turn on my camera so we can see each other and talk to each other. Couple of quick questions. How do customers ever see enough automation of what's happening on the agent side where they decide this is going to be completely automated? We're gonna automate this whole thing so it's not there's no agent interaction at all.
Yeah, we've definitely seen that. And so the way that might look is, we might see for certain intents that something like 70, so I showed that on average 75 to 80% of agent messages are being automated, but that's an average, right? So there are some intents that have 95% of their messages automated. And so for those intents, we can start looking at, okay, most of this has been automated by our responses. And so it's easy to look at the conversations and look at the types of things that are being said and design an automated flow that can agents or that can basically contain customers without them needing to get to an agent. And that's how we use the automated responses to eventually translate that into flows, so that customers don't need to talk to agents if they don't have to.
Yeah, that makes sense. I know this isn't your area, but it's a product question, so I'll just throw it out to you. Simple one. Curious for your company, you've talked about your Heather's talked about her AI models. Do you guys actually offer a UX UI component to these models?
Oh, yeah. So I focus a lot on the AI aspects and the measurement, but I work really closely with the designers and the product team. And every UI and UX component that we've developed for the automated responses, has been data driven, has been A/B tested. Everything that we put into this, we derive with data insights, and so all of the, you saw the usage increase over time. I would like to say that it's been, someone's really brilliant single idea. But the truth is it's really been a partnership with the design team and the user experience teams on, what small changes can we make and then study and then measure that will improve agent productivity. So we really take this principled way of studying and measurement approach when we think about the UX UI component.
Great. I am going to try to squeeze in one last. How do customers test the accuracy of the conversation summaries?
Of the conversation summaries. So we have two signals that we typically look at for the automated summaries. So one is, if the agent does not like the summary, they can delete parts of it, or they could rewrite their own summary. And so we can look at what we suggested and what they ultimately submitted. And that's a big signal about, when we got it wrong. And so the model will learn from that the same way that it learns, when we get something right. The other aspect that we have is we have ongoing annotation from real people who are tasked with measuring the summaries in terms of their coverage and topic granularity. So we want to make sure that the summaries are covering the salient points of conversations that are useful. So why the customer called in, steps that the agent took to resolve, and the final outcomes. And so, we have a scorecard that has some information about, granularity, coverage, precision, et cetera. So we take a pretty rigorous approach to that as well.
That's great.